Hey everyone. So that's the thing. Recently, I started to create some videos about Angular dependency injection for a new series which I call the Practical Dependency Injection in Angular Guide, which means that there's going to be a lot of focus on understanding what's going on with a lot of code example. But the thing is that I created it in my native language, which is Hebrew. Recently, I discovered that not everyone in the world understands Hebrew, so I decided to create another version in English, and hopefully uh, you'll get something out of this. So this is going to be the first part where I'm going to focus on node injectors. Let's get started. Tiny introduction. My name is Nir Kaufman. I'm a Google developer expert in Angular, working with Angular for the past 10 years since AngularJS. I'm a principal consultant at 500 Tech, based in New York, United States. I'm the organizer of the Angular IL meetup for the past 7 years. I'm a speaker, a trainer. I like to teach, I like to learn basically. And if you want to learn more about me, there's a link down here nir.life when you can find a little bit more info, but more importantly, all the relevant links to the code, to my slides, and so on. Let's talk about dependency injection. The first thing that we need to that we're gonna learn, that we need to understand about Angular dependency injection system is that we are dealing with two types of injectors. One of them is the module level injector, which called the R3, which is not going to be the main focus of this session, but wait for part two. And the other one is the node injector, the element injector, an injector that Angular creates for each directives or component. Well, component extend directives, so basically we're talking about the same type. So this session, we're going to focus on the element injector, which is created for each component slash directives and can be configured by using the providers array or view providers array which we can find on the component or directive decorator. So this is a tiny sketch of the demo app that I'm going to show you in a second. And I created this hierarchy of components because um, component are structured in hierarchy, and it's very important to remember this when we start dealing with injectors, because for each component, like I said in the intro, there's going to be a node injector which is created specifically for this component. And because components are structured like a tree, the node injector are like structure obviously as a tree. And this fact is going to be very important in a second. Let me show you the demo app. So I use Bootstrap to get some visual, something nice to look at it, not just console logs. And basically, we're gonna focus on this app module, which is the standard Angular application, where I created three separate modules. Each one of them is gonna load a component. So this is the app module, which got an app component inside of it, and I can route to another module. I call it an eager module. He's contain a eager component, and I've got some child components. So I've got a hierarchy of three components, three levels: app component, eager component, and child component. And there is another module which I'm gonna load um, lazy, which, well, I name it the lazy module, and it's got a lazy component. It's gonna be less important on this session because we're gonna talk about on element level injectors, but it is important. Let me show you the code. So if I go through the project, I just generated a simple project with Angular CLI, no dependencies, but Bootstrap CSS to keep it clean and focused. So under the app directory, you're gonna find the app module, which is our entry point. There is the app routing module, and here you can see that there is this eager component, which is coming from the eager module, and there is this lazy route that's gonna load the lazy module. And inside the lazy module, I'm going to render a lazy feature component. The eager module, you can find it right here. It's got a eager feature component, and it got another component called app child. The third module is, well, the app module, and I've got here a shared UI where I keep the child component. So if we're gonna start to talk about dependency injection, the first thing that I'm gonna create is some code that I'm gonna inject to other parts of my app. So I'm gonna create a new directory. I'm gonna call this directory services because that's the convention. And I'm gonna create a file. I'm not using the Angular CLI for a reason, because I don't want right now to generate this default decorator, the injectable decorator. And I'm gonna create a counter. I'm gonna call this file counter.service.ts. And again, if you're new to Angular, this is not a requirement. This is just a convention. But I highly encourage you to keep those conventions, because when Angular developers move from one project to another, it's very helpful to see a familiar structure of file names and folders. So counterservice.ts, I don't want to add it to Git right now. It's gonna be a simple class which we're gonna call a counter service. I'm gonna export it so I can import it somewhere. I'm gonna start by creating a constructor which I'm gonna use just for logging a message, so we'll know how many instances are created for this class. So I'm gonna use a little trick with console log because I want to log something colorful. So it's gonna be counter service instance, and let's give it the color red. This got nothing to do with dependency injection. It's just to create a nice colorful log, so it will be very so we can notice it in the DevTools. We're gonna see it in a second. I'm gonna create a count number. It's gonna be 0. Now I'm gonna create a getter for it. It's not required for this session, but like I told you before, I'm creating a series of sessions about dependency injection. So the next lesson and all the lessons that will come in the future will be based on this code. That's the reason I created this getter. I'm also gonna create a method called increase that's gonna take this count value and add 1 to it. So that's gonna be the service that we're gonna deal with in this session. Please note that there is no decorator. I'm not gonna use any decorator, and there are also no other dependencies. There will be in the future, but not now. So I've got a simple class. By saying simple, I mean no dependency, no framework, no Angular, no fancy syntax, just vanilla TypeScript. Alright, let me split my screen so we'll get this service in front of our eyes. And let's start by, where's my app? Here it is. Let's start by attacking this child component. So I'm gonna locate this child component in my code. Here it is. In the constructor, on the constructor, I wanna get an instance of counter service. So I'm gonna ask for it. I'm gonna make it public. Not considered to be a best practice, but I'm gonna bind it directly to the template, just to save some boilerplate code. So here's the count. It's coming from the counter, and this is gonna be a button, and I'm gonna call increase. Alright, which means that now if I go to eager component, we get an injector issue, which is kind of makes sense because, well, we ask for a dependency, but Angular doesn't know anything about this piece of code. Currently, it's just a floating TypeScript class somewhere in the project structure. The injector doesn't know about this code. Angular doesn't know about this code. So let's configure the app child node injector with this class. I'm intentionally using those terms so we can get used to the language. How do I do it? I create a providers array, and I'm gonna put my class right here, and let's hope for the best. Here's my child component, and each child component gonna get a fresh instance of this counter. You can see here in the console that I've got 3 instances. Every component configure its own node injector with this class, and for each component Angular creates a different separated injector, and that's the reason that each one of those components get a completely different state, and we get 3 instances. So we all good. This one was straightforward. Now, who's the father of this component? Who's the parent? Let's see. So I've got app component on top of eager component. So let's do this. Let's go back to the code, and I'm gonna close the counter service. We already know how it looks like, and I'm gonna split my screen right here. So we're gonna get the child downstairs and the app component right here. Let me just fold. You know what? I'm gonna copy this template. I'm gonna copy this button and this count, and we're gonna put it right here on the app component. And I'm also gonna steal the constructor from the child component. So I'm gonna put it here. And again, if now I'm gonna go back to the app, I'm gonna get an error for the same reason. But I want you to notice something. Look, you see here, Node Injector Factory. So remember, I started this session by telling you that there are basically two injectors in Angular. One of them is the node injector, the other one is the module level, the R3 injector. So if you look at the logs right now, you can see 2 different errors from 2 different injectors. One of them is the node injector, and the other one is the R3 injector. But anyways, the reason that we can see it, it's because if we think of the hierarchy. So I provided the counter service right down here at this child component level, but I try to inject it right here on the app component level, which is the topmost component, and Angular doesn't know, the injector doesn't know how to resolve it because he can't look down. He can only look up. He's traversing up the tree. So to fix it, I can do 2 things. First, I can config the app component node injector with this counter service. So now if we go back to the browser, the app component got its own instance, each one of the child components gets an instance, and everyone live happy. And we've got 1, 2, 3 services. What if I'm going to remove it from the child component? So I'm not going to provide it on the child component level. I go back to the code, and we see that we're not getting any errors. We get only 1 instance. And because I configured the node injector of app component with this code, with this class, all the child component can get a reference to it, because the way the injector resolved his dependencies is by looking at the node injector where I ask for the dependency, And if he can't find it there, he's start to move up the tree looking for the node injector that contains this service that know about this code that I want to inject. And if he find it, we good. But the problem is, well, maybe it's not a problem, but if you look carefully, they're all connected. It's a singleton. Everyone shared the same instance. Now, maybe that's exactly what you're trying to achieve, but anyways, that's a very good, I believe. You can tell me in the comments. I think it's a nice example that actually show you the hierarchy. All right, so we get it. Um, each component can configure its own node injector with some code, and we get a fresh instance. And if we are not providing or configure our own node injector where the component is actually asking for the dependency, the injector gonna go up the tree and look for a node injector that contains whatever we need. Now, what if I want to get some more control of what's going on here in terms of where I ask for a dependency? I want to know exactly where it's coming from for a lot of reasons. In future lessons, I'm going to show you some practical, real-world based examples, but right now I'm keeping it like simple and showing you a counter demo just to get used and learn about the hierarchy and the next topic, which is the resolution decorators. So if I go back to the slides, now we're gonna see how those decorators, which called resolution decorators, can help us get control. And we also see why it's why does it matter, why we need it, because well, I'm writing this code, I control the component hierarchy. Why should I use extra decorators and do some fancy stuff? So let's start by showing a scenario where you want your child component to be able to get a reference to the parent and to a reference to its own instance. So let's go back to the child component. Here's the child component. Now, just like before, I'm going to provide counter service on the child component node injector level, which is going to bring us to this point. 3 instances because I got 3 children, all right? And the 4th instance, it's on the app level component. Now I can go ahead, here is my child component down here, and I want to inject, I'm gonna call it the parent, my parent counter. The type gonna be the same type, the key gonna be the same key. There's no like other counter service, that's the same counter service, but this time I'm gonna use the following decorator: skip self. I just need to put the privacy modifier after the decorator, and let me reformat it so it's look a little bit more nice. Cool. So what's going on right here? I'm telling the injector, hey, look, I want an instance of counter service. So the injector gonna check the node injector, it's gonna find it right here, and it's gonna provide it to me, this instance. But then I want to, I'm telling the DI, hey, I want an instance of counter service, but when you look for it, skip my injector, skip the node injector, skip self. So if I'm gonna skip the child component, the next component at this hierarchy gonna be the app component, which means that this counter service gonna be resolved from my parent, and this counter service, because there is no special decorator, so we get a default behavior, gonna be resolved from my own node injector. Let me add a button here. And I'm just gonna change his color so it's gonna be a little bit more noticeable. And I'm gonna add some margin on the top, and I'm gonna call it increase parent, and here I'm gonna call the parent counter. So basically, if we go back to the browser, we're gonna see something like this. I can increase myself, and I can increase the parent, because I'm asking from the DI system, hey, give me the instance of counter service, but give me two references. One, an instance that you can resolve from my own node injector, the default behavior. The second one, give it from my parent. Now I can be even more specific and decorate this with self. So this way, there is no default behavior. If there's no provider on this node injector, I'm gonna get an error. Show you, all right? Now I'm gonna get an error on this line because I can't find nothing on my own node injector. This injection actually worked because here I skip myself. So how do I avoid from like getting this kind of errors? Well, I can add an extra decorator called optional. And what optional gonna do is, if the DI, the injector, can't resolve it, it's not gonna throw an error, it's just gonna return null. So if I go back to the code, let's take the eager. All right, cannot read property count of null because now it's null, but we are not like crashing completely. So I can come here and I can say, all right, we said that the counter might not be here, it's optional, so I can do this, some TypeScript magic, and that's not gonna help me too much because it's still null. Yeah. What I did wrong, why not? Well, technically I think it's gonna work, but you get the idea. It's not that important. I just want to show you that the optional is not everything gonna crash. Now I'm crashing just because I don't have it. It's null. So if I remove this button, the code's still gonna work. I'm not gonna get any errors whatsoever. Or do I? Let's fix it. That's the beauty of first of all, I'm gonna put the optional first. That's an optional self. Try to resolve it from myself. So the counter might be null. If that's not fixed the code, I might gonna need to ng-serve again. No, that's, yeah, almost. Let's see where it's coming from. Child component TS. That's the beauty of errors in the template. And it's still running this piece of code, and that's the reason it failed. You know what? Let's be more, let's do it even. Let's just remove this code. I don't want it to crash. All right. Oh, yeah. I was right. That's what I like about live coding. You get an error, you deal with this error, and we learn something. Look, this counter, where I want to show the count, he might be undefined. It might be null. So I need to add a question mark here as well. And now the code won't crash. So I can show you the example. Right? So I don't have any count. I can still deal with my parent, but my own node injector resolved to null. Now, like I said before, you can ask yourself, all right, what's the point? I mean, what's the point of like using self if I know for sure that I'm writing this code, I'm gonna provide a counter here, and if I'm providing this counter service here, I want a default behavior. When I'm asking for an instance, give it to me from my own node injector. Now maybe I have some kind of a scenario like I just show you, and I want to update something on the parent, so it does make sense, but most of the time it's a little bit strange, this skip self and self. And so I want to show you like a valid use case. Well, because this eager module is easy, we are not loading it lazy, so we've got a predictable environment. What I'm trying to say is, let's talk about the lazy loaded model. You just lazy loaded some module. Now, may when you load it, you might have a counter service provided in one of your parent components. You might have one, but you might not have one, because that's the nature of lazy loaded code. Most of the time, when you lazy load, you might have a scenario when your code is being loaded in two different scenarios. In one scenario, you might have a provider defined up the tree, and in another scenario, it might not be there. And this is where the resolution decorators actually kicks in. Let me show you what I mean. Let's do this. I'm gonna go ahead and open the lazy feature component. And the lazy feature component, actually I can steal the code from the child component. I want to take the exact same thing. So I'm going to take this, and I'm going to take all of this. And I don't need it here. Alright, cool. So let me first, I'm going to inject everything that I did before. Alright. Now it's make a little bit more sense. Let me show you some piece of code that I might be using. So I'm gonna say optional skip self and self. I'm gonna provide a counter service right here. I can fold this template, it's not relevant. Because this component is being loaded lazy, I might have a counter service on one of the parents. So now I can do a simple check. I can create here a counter service. The type gonna be counter service, and then I can just use some kind of condition by saying, first of all, look at my parents, because if I've got a parent counter, I want to use it. This counter service will be the parent counter. Otherwise, this counter service would be a fresh instance that I provided from my own node injector. So let me fix the code for a second, because now I want a counter service, which can be either the parent or provided from my own node injector. Alright, this is gonna be, we don't need this. Now look at this code and let me know in the comments if it makes sense to you. I'm lazy loading the counter service. I might have a counter service, I might not have a counter service. Actually, let's try to simulate the scenario. So here, that's my home page. I'm loading the module lazy, and I've got a counter service, which means that now, as you can see, I'm using the one that was already there. Now let's think about a scenario when you've got multiple pages and you might load this component and you don't have any parent that actually defined this service. My code gonna crash? I don't know. Let's check it out. I mean, I do know, but let's check it out together. Anyway, So here's my home page. Let me refresh everything. No magic. I'm loading my component lazy, and it's not crash, it's giving me my own instance. So when you start lazy loading your code, those resolution decorators starting to make more sense, because there is a lot of scenario when you lazy load a feature in different pages, and sometimes you've got a service in your scope, and if you got one you want to use it, and if you don't have one you might want to create a new instance of it. So this is where this technique shines. Let me show it to you again. All right, super cool. We almost covered everything we need to know about the component level injector hierarchy. Almost everything. There is another decorator here which works together with skip self, and this one called host. And the host, let me remove the, actually I can leave the optional. The meaning of the host is, hey, try to inject, let me go back to lazy, all right? Try to inject the service, but start looking from my parent, skip self. So start looking at the app component. Now, if you find it on the app component, that's cool. Actually, enough theory. Let's try to actually simulate this situation. I'm gonna take the child component. I'm gonna take this same code, exactly everything I did on the lazy feature component, and I'm gonna move it to the child component. And here I'm gonna remove this and I'm gonna put it right here on the child component. And the lazy module feature gonna have a child component. So now let's see what's going on. Yeah, I'm getting a node injector issue. Let's try to resolve it together. The node injector saying I can't find any counter service, but wait a second, why not? I mean, let's explore what's going on. Well, I don't have it on my own injector provider, which makes sense, so the self is probably failing. Let me provide it here, the counter service, right? And go back to the app and let's see what we've got now. So I'm not getting any errors. I'm gonna hit the lazy and everything works. Everything works because, well, I've got a code that it's gonna be very hard to make it fail. But let's make it fail anyway. Let's say, alright, let's say that I don't have the self, which means that I'm gonna hit this line. Go ahead, skip myself, alright, but stop at the host, which means that if you go back to the hierarchy, let's see what's going on here. We are here at the child component. I just generated an error and tried to make it work. Beautiful. Alright, back here. We are here on the child component. My direct parent is the lazy component, and then I've got another component, app component. Now what I'm gonna write now is I'm gonna use those resolution decorators to tell the child component, hey, get the counter service, skip myself, start looking at my parent, and stop right there. So if you won't find it here, don't move ahead and try to, um, get it from the parent component. I'm restricting, I got like a restriction. You skip myself, but you stop at the host. Let's see if I can make it happen. So this is an optional skip self. There's not gonna be, well, it's gonna be a provider here. Let's remove it. Let's skip this. All right, let's read this line of code. All right, optional skip myself, look for the counter service, but stop when you reach the host, which means that theoretically, if I go to app component that I provided right here, that shouldn't work. Let's see if it is working or not. I'm gonna hit the lazy and everything crashed. I mean, cannot read count, count is undefined, and that's only because I restricted it with the host. If I remove the host, I'm gonna get a default behavior, so Angular gonna climb up and find it on the app component, which is not my direct parent, and everything work. So the host give us another like resolution by saying skip yourself, but don't go all the way up. When you hit your direct parent, you can stop right there. So I'm getting more control about what's going on. Great. Hopefully this explanation makes sense to you. Now I'm going to show you the last API to control this hierarchy. Then I'm going to summarize the injector, the node injector level hierarchy, and I'm going to give you a teaser about what I'm going to speak on the next lesson, and wait for your comment to see if I did good or you completely confused, and then I'm going to answer your questions. So all right, so now I want to show you another common use case. And this common use case is sometimes we've got a component that wraps other components. So let me show you what I mean. Let me create a component, quickly create a component. So I'm gonna use the Angular CLI now. I'm gonna use a component, I'm gonna call this component wrapper. And you're gonna understand why in a second. And this is my wrapper component. You know, just to get a nice styling, I'm gonna paste this whole bootstrap party right here. Let me clear the screen so you see exactly what I'm doing. Cool. Let's call this a wrapper component. Wrapper component. And the wrapper component use the ng content, so I can wrap whatever I want. Let's remove the stars. Let's keep it as clean as possible. Cool. Now I'm gonna use it. I'm gonna go ahead to my eager feature component, which got 3 children, and I'm gonna wrap this child with the app wrapper. I'm gonna go back to the app and see if I've got everything working. Yeah. All right. So look what's going on. We've got the app component. Then we've got the eager component. Then we've got some kind of a wrapper component that wrapped the child. Now we're still getting a counter service because we resolved it from the parent, if you remember. Now let's say that the app wrapper, let me split my screen, the app wrapper wrap the child component. We're gonna modify the child component code a little bit. I'm gonna remove the optional. I'm gonna remove the skip self, but because I want it to fail if something gonna you know something gonna not gonna work. So we're gonna keep it like just like we did before. It's gonna be a counter. The default behavior. I'm gonna fix the template. So that's gonna be the counter. All right. Now we're gonna get we're not gonna get an error because the child component, now we got the default behavior, and on the app component level we do provide the counter, so it can be resolved. To generate an error, we will visit the app component for a second. Here it is. Remove it from here, and that's it. Now let's get an injection error, a node injector. We can see the node injector here, and then we see the R3, which is the topic of our next session. But obviously, this code is not gonna work because the child trying to inject something which is not exist on any node injector in the entire hierarchy. All right, but the direct parent of this child is this wrapper. All right, the wrapper wraps whatever. We can pass whatever we want. In this scenario, we pass the child. So um, if on the wrapper component, I use the providers array and provide the counter service, I expect it to work because the child component is wrapped with the app wrapper component, and the app wrapper component configure its own injector with the counter service. So let's see if that's actually did the trick. And yes, it is, which is cool. But let's think about it for a second. All right, the wrapper component is a generic component, which means that it can wrap a lot of things, a lot of stuff. Now, maybe on the wrapper, I have my own counter. Let me inject. Let me inject it here. All right. So now, let me just show you how it looks like. The wrapper component got a counter. The child component get the reference to the counter of the parent. Both of them are synchronized. We already seen how we can modify the child component, but again, let's think about it for a second. Right now I'm wrapping the child component, but I might wrap any other component whatsoever. Now I can use the resolution decorator here and just limit my limit the limit the scope of this dependency resolution, but I'm not gonna do it for each component. What I'm gonna do right now, what I'm gonna show you is I want to use the counter service on the wrapper component, but I don't want that any content child, everything that I'm gonna wrap, gonna get gonna see the service. So I'm gonna change it from providers to view providers. And by doing this, what I'm actually doing is that, hey, this counter service, I'm gonna provide it, but only to my view and any of my children, not to any projected content. If I'm gonna wrap a component and this component is injecting the counter service, I don't want it to get it. That's it. I just don't want to get it because it does make sense when you think about it. Let's see about if this actually works for us. So the code failed because the child component now, right? The child component asking for a counter service, but it can't find it on the parent because the direct parent is the wrapper, and the wrapper didn't configure its node injector to make the counter service visible to anything that is not part of this, directly part of this view. Projected content is not a part of this component view. So I can control the visibility of my service. I can control the scope to just the view provider. And now I don't need to go and each component that I might wrap to use all of those resolutions. Let's think how we can fix it. If I go back to the child, well, I'm not gonna get it from my parent because it was restricted. But what's gonna happen if I'm gonna go to app component again and provide it on the app component? Let's talk about it. Let's see what's going on here. So the child component asks for a counter service, which is not exist on the child component node injector. So the injector wanna go up. Now he won't find it on the wrapper component because the wrapper component provided the counter service, but only for its own view. Instead, it's gonna get it from the app component. That's nice. Which means that if I want to prove it to you, which I want, I can take the same HTML, put it on the app component, inject the counter right here, counter service. Let's make it public. All right. So the child component, as you can see here, getting the instance is just skipping the wrapper component. The wrapper component configure its own node injector with a counter service, but it restricted its scope. We use the view provider, so it's provided only to the wrapper component view. So I've got a child, but the injector can't find the counter service on my direct parent, so it go ahead and look upstairs. So let me summarize. This first session was about the node injector, the element level injector. Angular create an injector for each component directive, which are technically the same type because component extend directive. So if you want to provide our code or configure the node injector, we can write a simple class like we just did, this counter service, and then on each component we can configure the injector using a provider, which means that for each component we can decide if we want to configure the node injector to know about our counter service, and every time we do it we get a fresh instance. And because our components are structured as a tree, the injectors are structured as a tree, and the default behavior of Angular DI node injector is to look up for for the code that we want to provide. Just go up the tree and look for it on any node injector until you hit the app component, and then that's a different hierarchy which we're going to talk about in the next session. Now, if you want to control this, we can use those resolution decorators like self, host, and skip self, which started to make sense when we lazy load some code. Because when you lazy load some code, sometimes you will have a specific service in on your hierarchy, and you might want to use it if it exists. But on the other hand, you don't want to code your code to fail if you can find it. All right. Now, if I want to control the scope but from the other side, so each component can decide whatever the node injector configure the service to be visible to the component and all of the children, or restricted to the component view and the direct children of the view. The projected content is not part of the view directly. So that's it for the first session. Hopefully you learned something new, or at least you got like a fresh perspective of what's going on. Controlling and understanding this hierarchy, once you get it, and hopefully the demo showed you, it's become very natural to control the amount of instances and the resolution, and exactly which instance we're getting from each level. Because the bottom line, that's a tree. We've got a tree of components, a tree of injectors. The default behavior is straightforward. On the next session, we're going to take it a step further, and we're going to start talking about what's happened if we can't resolve the service from the node injectors. Because after we're done with the components, we start dealing with Angular modules. But I don't want to spoil the surprise. So I'm going to go back to my introduction slide just to wrap it up. Thank you very much for watching. If you've got any questions whatsoever, you are more than welcome to get in touch. You can find my email, my Twitter, my GitHub, my SlideShare, everything you need by visiting this tiny personal website, nir.life. The code that you just seen, this playground with all the services, is already on GitHub, so you can find it on my GitHub account on my repo. If you can't find it, please let me know, and I'm gonna share those slides soon. So if you enjoyed, let me know. Drop a comment, and I'll see you soon on the next lesson on practical dependency injection, where we're gonna start dealing with the other injector, which is the R3, which is very interesting. So, yep, I think that that's it. Thank you.